Chloride is a common anion in biological systems. Chloride reacts with silver, the silver ion from silver nitrate, and analysis for chloride is often done through its reaction with silver, the silver ion. So if you want to analyze for chloride, it's not a big deal. If you want to know how much salt there is in something, a very common procedure is to analyze for the chloride and then convert the percent chloride into the percent salt. My attitude towards something like this is I look at the percent chloride, I say 1.5% chloride, and I think, what does that exactly mean? And then I want, what percent salt is that? What exactly does that mean? So I make an example. Let's say we have 100 grams of potato chips. Of this, 1.5% is chloride. So 100 grams of potato chips, 1.5 grams is chloride. And our question is, how many grams are salt? So this may seem redundant, and perhaps it is redundant, but I like this because now it gives me confidence that we're dealing with 1.5 grams of chloride, which is something that I can understand easier. And now we need to know, how many grams of salt do we have? Sodium chloride has one molecule, one atom of sodium and one atom of chloride. So you say, well, one atom of sodium, one atom of chloride, there must be 3% sodium chloride. But as we all know, the sodium and the chloride do not weigh the same. And so the relationship between the molecules do not translate into a gram-to-gram relationship. And that's what stoichiometry is all about. This little exercise is a little exercise in stoichiometry. So we have 1.5 grams of chloride. In order to find out how much sodium we need to find out how many moles of chloride we have. And the calculation, of course, is grams divided by grams per mole. When I was a kid, I was real smart, thought I was smart and figured all this out. Now I just do it so the units come out. It's pretty obvious that the grams will fall out of this and the moles will end up on top, so that's good. And then the moles of chloride should match the moles of sodium. So the moles of sodium will be, X is on top, the grams per mole, which is sodium is 23 grams per mole, will be on the bottom. And then the variable is the grams of sodium. And to simplify this, we should recognize that we don't care how many moles there are, we just want them to match. So we take this big formula here. It's not as big as it looks. And cross multiply and divide. So 35.4 times X, grams per mole. Look at the units you got, grams per mole. And the X's doesn't have units yet. And then is equal to 1.5 grams times 23.0 grams per mole. So this one goes to here, this one goes to here. See, these two are the same. Cross multiply and divide. Now divide the 35 underneath and you end up with 1.5 times 23 and divided by 35.4, and you end up with 0.975 grams of sodium. So we add our 1.5 originally. This is the chloride. This is the sodium. And we end up with 2.5 grams, and this is, of course, sodium chloride. And it's kind of a cool little exercise. I think there's some assumptions here that are somewhat obvious. We're assuming that the chloride all came from salt. We're assuming that the anion associated with the chloride is always sodium, which of course it's almost certainly not always sodium. Like you could have sodium chloride, potassium chloride. Magnesium chloride would not be common, but potassium chloride certainly is. this sort of calculation is fairly common in laboratories.